Hi, welcome to the Chico Math Lab differential equation problem solving session. All right, here is the problem we are going to solve today. Is xydy equal to y squared plus x times dx here. All right, let's go ahead and get a start. Okay, so when we first time, when we see this problem, it looks like this is a nonlinear type of the problem. Got xy here, got the y squared plus x here. I will always kind of recommend to see, and let's rearrange it to see if we can change this equation to a better recognized form. Then we can decide if we're going to use the linear differential equation or nonlinear approaches here. All right, so first things here I will do is I will do divided by dx both sides. So I will have a dy, xy, dy, dx is equal to y squared plus x. All right, and then what I want to do is here I will simplify a little bit more to move everything like this xy term to here. Okay, so now I will have a clear view about dy dx. Okay, so my right-hand side is y squared plus x over x times y, right? So I can separate this one to xy, y squared plus xy, x. So now I can simplify this. So xy squared, so what I'm going to get y over x. And then the last ones here, the xx cancel, I will get y to the -1 power. Now I start to recognize this. This is kind of the linear forms here. So I will move the here. So I will say this is a dy dx. Now I move this term to the left-hand side here. All right, so this will be negative. Then this I put this is 1 over x, and the y is equal to 1 to the -1. Well, very nicely, it seems this one will match what the equation we are very familiar equation is a Bernoulli equations, right? So for the Bernoulli equation, let's try to remember that. So like every time, I always like to rewrite it. So this is a dy dx plus the px and the y, then is equal to the qx and the y to the n. So looks like our equation satisfies this Bernoulli equation. So what is this one here? This is my px function, right? And the qx is just equal to 1, and this is n is equal to -1. As soon as we identify this is part of the Bernoulli equation, then we can just follow our step. So I hope that everybody, if you watch the previous 4, you should be very familiar with those steps, right? So what is the first step? The first step, I'm going to define the new variable v, and the v will be y over 1 minus n. So this is y minus -1. So what I have here, I have v equal to y squared. Then the next things here, I'm going to take the derivative. So I say dv dx is equal to what? The 2y dy dx. Okay, so this is the first step. And then remember, then the next steps here is I try to, find what is dy dx over the dv dx. So here we say if from the equation number 1, if we divide it by 2y, we will see the dy dx is equal to 1 over 2y dv dx. All right, so that's what we try to, okay, so that's what we try to do. Then the next steps here is try to replace the dy dx from my original equations and with the dv dx here. All right, okay, so now this is step number 2. Then step number 3, let's replace with my original. Let me highlight this one. So I'm going to replace into here the dy dx. I'm going to replace with dv dx. All right, so we see the dy dx is 1 over 2y. So I can say this is 1 over 2y dv dx. Okay, now hold the other things here. So this is 1 over xy equal to 1 to the negative 1. Okay, then the next steps here, I want to simplify the dv dx. So in order to simplify the dv dx, so I can do is just times the both sides with the 2y's, right? So the both sides with the 2y, I can simplify it. Okay, so here is so 2y over 2y, so this is a dv dx. Then minus 2, here is x. Then y times y is y squared. And then it's equal to my right-hand side. Y and y to the negative 1 become 1. So here it's just going to become 2 here. All right. So because this is a 2, and also I know v is equal to y squared, right? So in here, like we defined v equal to y squared. So now I can change everything to v. So this is dv over dx minus 2 over x to the v. Okay, 2 over x to the v equal to 2. Yeah, so let me use a different things to highlight this. So this I've changed it to the another linear differential equation. Right now the variable is v. Okay, so now since I changed to this simple linear form, so what I can do is here, so step number 4, as always, I need to find the integration factors. Right, so I will do du dx. Define the variable du dx is equal to what? Is equal to this new px here. So it will be negative 2 over x times u. So remember, after we defined this, what do we want here? We want to solve for u, right? So in here, in order to solve for u, I can just do a separation, right? So I can use a separation method. So it's a du over u is equal to negative 2 dx over x. And then when you integrate, you will get the ln u equal to the negative 2 ln x, or you can move this negative 2 in, so this is x to the negative 2. So finally, I get this integration factor is u is equal to 1 over x squared. All right, so this is u equal to 1 over x squared. Then our next step is going to be, after we find this integration factor, then I need to multiply the previous, the one highlighted in the yellow, with this integration factor here. So that means I need to times 1 over x squared dv dx minus 2x y squared. Here, dv dx minus 2x v and equal to 2 over x squared. All right, so let's start my color coding. I need to, multiply this integration factor on both sides here. Okay, so now let's kind of see that. So this one will be 1 over x squared. Okay, so this one, maybe we can simplify that. So this one here, we will just do, you put it like 1 over x squared dv dx equal to 2xv equal to 2x squared like before. So we know these numbers here, this is here, okay, is the, if you take the derivative of the 1 over, if you take the derivative of the 1 over x squared and times v here, okay? And then, okay, so I think I made a careless mistake. So times, so here this would be q, okay? So here this is going to be q here. All right, so now this one here is equal to 2 the x squared. So if you want to check whether you did it right, so you say, okay, product rule, right? Hold the 1 over x squared, take the derivative of v, so it's dv dx, then plus, right? So plus holding the v, take the derivative of 1 over x squared. So 1 over x squared is just negative 2, and then x to the negative 3. So it's a match what I have on the left-hand side. All right, so that is what this one's here. Then the other things here we can do here will just be, after this one, we can just integrate both sides here, right? So I can integrate both sides. Okay, so when I integrate, this is the derivatives, right? So that will just be the self is x squared v, and this is then when you integrate this one, it's negative 2, and I think it's the x equal to negative 1 plus c. All right, so now in here, I know the 1 over x squared v we defined in the very beginning. If you remember, the v we defined the very beginning is y squared here, right? All right, so I replace this as y squared is equal to negative 2 x to the negative 1 plus c. Now I'm going to plug in my initial condition to solving for the c's here. So x equal to 1, y equal to 2. So this will be 2 to the square over 1 to the square equal to negative 2, 1 over 1 plus c. All right, so here I will get 4 is equal to the negative 2 plus c. So what is my c value? My c value will be equal to 6 here. Now I finally solving my equations here. So by plugging in the c back to here, so my equation will be 1 over x squared, y squared is equal to negative 2x plus c, 6 times 1 over x squared. So it's y squared. So I multiplied x squared both sides to simplify it a little bit. So I got the y squared is equal to the negative 2x plus 6x squared. That's right. Okay, after I did that, then I will take the square root. So y can be plus or minus negative 2x plus 6x squared. Okay, so in here, take a look here. Because my initial condition y1 equal to 2, so y is greater than 0. So that is why my final answer will be y is equal to the positive negative 2x plus 6x squared. Okay, right, so this will be my final answer. Okay, so this one's here at the beginning looks kind of complicated because it doesn't look like it's a linear, but now when you know, kind of moving around combined, it does show up to be a very nice Bernoulli, you know, the equation here. So then we can follow the methodology. I hope this helped and helped, you know, your work on the differential equation. Okay, guys, I will talk to you when we solve our next problems here. Have a good day. Bye.